benchmarking project. So we got, somebody posted on the Fortran. Actually, I can maybe share my screen. Let's see if I can do that. I'll do share screen. I'll do desktop share. Cool. Can you see my screen?
Yeah, that looks good.
Awesome. So when I go to the discourse, somebody posted Julia here, improving Fortran results in the Julia benchmark. That's how we got the idea, I think. So actually it was Lawrence. Yes, Lawrence posted about so he spent some time improving the Fortran benchmarks in the Julia, I believe, benchmarks, and so we decided we should create a repository for benchmarking. And in fact, we started it, and it's called just benchmarks, Fortran lang/benchmarks. And so we are discussing like exactly how to approach it before we do something in the issues. And I'll just kind of very briefly kind of mention some of the biggest issues we have to kind of figure out. Is the biggest one probably is the criteria, which is what should we allow, like how should we do that? And it looks like at least nobody seems to be to oppose the idea that I suggested is to have have multiple versions of benchmarks. For example, even in Fortran, have multiple versions, and then benchmark it with various compiler options, and just collect the statistics, and then and also collect it on multiple hardware. Ideally, but initially we'll just pick some computer, do it there. And then once we have the statistics, the question is, how do we visualize it? What do we do with it? And so one kind of initial way we can do is we can split the benchmarks into multiple kind of like sections. One can be just Fortran only. It will be benchmarking different Fortran compilers. Another can be languages comparisons. So that could be Fortran and C++, Julia, and so on. It seems it makes sense to not allow any inline assembly. And then we'll have an assembly section which allows anything, like any language, any assembly, inline, anything. And that way I also suggested that we should try to kind of answer, I guess right here, transfer for us, like, you know, for Julia, it might make sense to look maybe at the different kind of sections, but for Fortran, it makes sense to see, we would like to show that Fortran is a good choice for its mission. And I kind of suggest one of the mission could be, one way to say the mission could be enable scientists, engineers, and other domain experts to write programs that naturally express the mathematics and algorithms employed and are portable across HPC systems, remain viable over decades of use, and extract high percentage of performance from the underlying hardware. In other words, that's why I suggested it'd be nice to have a section that doesn't allow inline assembly, because that way we can just kind of, that section I'm hoping could show that in Fortran, you write it in Fortran and stick in Fortran, no assembly, and still get very good performance. And then we can compare against other languages like C++ or Julia, and also not allowing assembly. And then I think still have to have an assembly section which would allow absolutely anything. And so that people can kind of see how close you are to the absolutely best optimized assembly version, for example. Yeah. So I think that's all I have. Do you have any? I would welcome any kind of feedback on what we are trying to do here.
Andre, I have a question, Milan here.
Yes.
Do any of these comparison categories include, say, just benchmarking various Fortran features and operations? So I personally am most interested in knowing, okay, how does a certain maybe arithmetic operation perform over whole arrays for various sizes of arrays and dimensions? How does, say, traversing nested derived types perform as you scale that? So things like that, various elements of the language within the same compiler. What do you think about that?
Yeah, so I think we should have that. And I think what it seems to me that we can have hundreds of benchmarks, you know, so it can be, we can have a very large, you know, benchmark suite, and this can be part of it. So I can imagine once you start benchmarking parts of the language, we'll have hundreds of benchmarks. Then, you know, we can automatically run it, collect, you know, with different optimization options, different compilers. So I think that can be done. It seems to be, no opposition there. The question is then how do we then visualize it? How do we then present the results?
Yeah, I think this is going to be the issue is, and I agree with Milan, we want to be looking also within the Fortran language, and ideally the ultimate goal as well is to kind of present people with useful results for what kind of Fortran features might have a little bit of overhead associated with them, or what kind of optimization flags work with what kind of algorithms. So I think the big question, as you point out, is we need a way of kind of describing all of these possible combinations that we're going to be running, and also presenting it in a way that's useful to people. So I think there's an issue on that as well, possibly, but yeah, that's an important point.
Yeah, and I think we'll iterate on the visualization.
May I make a comment? Writing good benchmarks is hard. And my experience is that when people write benchmarks especially for individual language features, the results are not representative of what you would see in a real application. And many times they don't understand that the compiler said, oh, well, you didn't actually use the results of this, therefore I'm going to throw away all of that work you did. And boy, it runs really fast. So I would caution you in terms of trying to create benchmarks to test specific language features that it's probably not representative of what's going to happen in a program, in a real application. These I'll call them unit benchmarks. I don't think they provide much helpful information. If you look at let's say spec, those are derived from real world HPC applications, and people who are experts in this spend a lot of time making sure that these test what people are really interested in is how do I make my application run fast, not how many how many microseconds is this particular addition of an array or whatever. That's not very useful. And also, compilers are very complicated. They can merge operations across multiple statements. So I would suggest that you don't spend a lot of time trying to do micro benchmarks, but take real applications like that runge kata thing. There was a company in England, I have to go back and look at my records, who had a whole suite of Fortran benchmarks with results comparisons. And especially with floating point, you can't just compare the exact output. You want to have some kind of a delta for what the results are. So it's tough, and this is a good project, but don't think that it's going to be easy.
So I agree actually with everything you said, Steve. And for me personally, I'm more interested in benchmarks, kind of like almost like end-to-end programs, really. And that's what I think is most useful for me. But I know other people have different different wishes, and so I think the way to approach it is to just have kind of a framework where we can run these benchmarks, and we'll have hundreds of them. And then what you mentioned is, I agree. Like, for example, you and I will probably look more at the benchmarks which are more representative of the whole, let's say, some code, like the Rangekata benchmark. I think it's great example. There's others, and some other people might look at other sections, so we just have to kind of figure out how to present it.
I would say that these micro benchmarks are more interesting for demonstrating how you can implement a certain feature. As demonstration of the code and the code, the features of the language, rather than indeed the actual performance.
Can I just make a comment? sorry if I didn't introduce myself. I just jumped in. My name is Emanuele Pagone. I participate from time to time. Can we leverage the list that we have on our on Fortran language website of packages that we have exactly to write this sort of benchmarks? That would be a good idea, maybe. I don't know if Steve Lionel meant Polyhedron. I think there was the company. Yeah, that was. I don't remember the exact name, but I was some time ago. I used to check the website. They were considering real existing codes, well developed and well established codes, and they were calculating the mean, the geometric mean, I think, of their times for different types of different vendors, basically. Well, there was also G-Fortran and G95 at that time. I think we can use what we have in the list of our libraries and do something similar. To be honest, I need to dig out as well the website of Polyhedron, if I remember correctly the name.
Yes.
But yeah, maybe someone else with more experience than me will remember the exact name.
Yeah, that you are absolutely right. It was Polyhedron. Thank you. And I remember when I was working for Intel, we had a copy of it, but Polyhedron, the company, is no more. So I don't know whether those are still available.
These are some really useful points, actually, especially for someone like myself who doesn't do any benchmarking as a job or officially. So thank you for that. I think we should probably move on to our two main topics because there's, I think, quite a lot to discuss there. So does someone want to start off with the discussion on the standard library?
Okay, so maybe I can just give a quick intro. So I was hoping that we discuss the structure of files and modules of the standard library. So I forget who it was. William Claudius. Is William on the call? Perhaps not. So he raised an issue of basically the structure being somewhat awkward or confusing, which to me it's sort of it made me think about like how I perceive the current stdlib structure. And to me, perhaps the most confusing part is still the relationship between experimental versus stable development branch. Currently, we only have experimental, so it's not really, it doesn't really matter right now in practice, but going forward, how do we see that? And I think a few of us had a somewhat different ideas on the best approach. And I think Andre was the main proponent of having an experimental development branch, which only contains items, modules, procedures, functions that have not been stabilized. Once they're stabilized, they move to the so-called stable development branch. They're removed from experimental. So experimental and stable are not overlapping in terms of functionality. And then perhaps the stable branch has a more limited set of functionality, but that can then be, because it's stable, there is a promise that the API won't change in the future. Perhaps some optional arguments can be added. Perhaps the internal workings of the procedures can be improved in stable, but the API doesn't change. So from the user's perspective, it is stable. To me personally, that's sort of, it's a bit, I think, a clumsy approach in the sense that you need to sort of manage this on the source level rather than on the version control level, which I think most of us are used to. So just for an example of a version control kind of management of source, you would have stable and experimental in the same code base, except there's procedures that are experimental, so they may or may not change their API in the future. And there's those that are stable. But when you check out, say, a branch or the master trunk of the repository, you're getting both the stable and the experimental in one, basically in one source. Right now,
that's what I want, right? That's what you just described. That's what I'm proposing.
Right, except you're separating on the source level. So if you want the client code to use a procedure from the stable track and a procedure from the experimental, they need to pull them from the stable module and from a separate experimental module rather than the same one. So maybe the difference is really superficial here, really, and it's really about how we manage this. Ultimately, this is not. For me, it's not a showstopper. It's more like, okay, it's kind of. I struggle with my, in my mind, getting used to the structure and like how we're going to work with it, especially once we do have stable. And I was thinking the implications of separating the way we are doing it now and the way you propose. That could make it easier if we want to ship just stable branch as a separate thing. So if you want to have a tarball of just stable functionality, then I think that will be easier rather than if they're separated by master branch, development branch, and feature branches, and so on. So I'd just like to sort of solicit feedback and get input from whoever wants to chime in.
Can I ask a possibly slightly higher level related question? Because I briefly skimmed through that particular issue, and I was struck by the kind of, it seems to be a foregone decision that basically STD-lib is going to be 100% backwards compatible forever. This kind of rings alarm bells a little bit to me because ensuring or guaranteeing backwards compatibility forever is quite a big promise. And there are actually, I think someone mentioned it, semantic versioning is an alternative solution that's used pretty much ubiquitously everywhere else as an alternative to this. And it gives you a lot more flexibility in terms of kind of improving things, because essentially if you're guaranteeing backwards compatibility forever, you've got to write it right the first time. So obviously we have experimental, but if I had that rule in my own code base, nothing would ever get out of experimental, basically. So is there the option to introduce semantic versioning into STD?
So I would say we decided about, I think we started STD-lib in January, I believe, or something like that. And so
December
even.
But I think we did a split on experimental and stable in January.
Okay, so we essentially, I wanted to have something that we can start working as opposed to, figuring these things out, because these are tough problems to figure out. And so I realized, if we have the experimental, we can start working right away. And it allows us the option to discuss it. So I would say absolutely, yeah. Any of the proposals are on the table. I don't think it's set what we have to do, and also I don't think it's set what STD-lib has to be. When we started it, the idea was to, at least that's how I understood it, like an extension to the Fortran standard of things which might be really hard to get into the standard. As an example, a lot of people proposed all kinds of functionalities regarding strings and all kinds of small utilities, which are kind of simple functions. And the issue with putting it into the standard is that it's a lot more work. You have to it's just a lot more work. And so by and it makes more sense to have it in a library that's separate from the standard, because if it's put into the standard, then every compiler has to support it. But if it's separately in a library, then that library can be shipped with the compilers, and so we can achieve the same thing, and kind of everybody would agree with the workflow. So that was my initial understanding. But so I've viewed, the backwards compatibility like a Fortran standard backwards compatibility, which means you have to be very serious about it and not, Fortran standard doesn't have semantic versioning. And so I viewed, we were trying to figure out some ways to kind of achieve similar. We don't have to do it that way. We can move and just develop stdlib as just a library, in which case we can have semantic versioning. And the idea is that once you bump the first number in that semantic version, you can break compatibility. It's an option, I think. You just have to kind of decide what makes sense, what makes the most sense for Fortran.
So I think when you're trying to discuss how to organize experimental versus stable, the questions kind of become how easy and how explicit do you want it to be for your users when they're trying to decide whether to use functionality from stable versus explicit? And how easy do you want it to be for them to be able to use both, right? Do you want it? Do you want to make sure that they're explicit when they're using experimental features so that they don't accidentally use experimental features and rely on that? Or do you want to make it really easy for them to use experimental features without having to do extra steps in their code? Right, so you have to find that balancing act and figure out exactly what your use case is going to look like for your users from that standpoint.
Yeah, I agree with Brett. That's the bottom line. How we want this to look like. And yeah, it looks like we don't really have an answer right now. But I thought it'd be good that we have this sort of in the back of our heads to think about it.
Yeah, Arjen, do you want to ask your question? You have to unmute yourself.
Sorry. Right now, the library is one big thing, right? I can imagine that the different topics that are covered by it could have their own version, so that breaking the API in one part doesn't really mean that you have to use a different semantic version for the whole thing. The library itself would still be one entity, but you could use different stages of the development for different parts that you are interested in.
So are you thinking of having like different version per module or per function?
Well, per module.
So if
the directory, wrong one. Well, you could say, look at linear algebra, statistics. Those could have different development paths, and therefore different versions.
Yeah, but so let's say the statistics. So we have some functions already in stdlib. Right now they're in experimental. Let's say we, in the year we'll move them to stable. Let's say somebody else proposes a new function for the statistics. So what I had in mind, it should not go into stable. It needs to go in some kind of experimental. And so what I was thinking with the current approach, we would have statistics that's stable. So we stdlib underscore stats, let's say.
Yep. And
then you would also have stdlib underscore experimental underscore stats. And that would contain functions which are not yet stable. That way we'll have both. If we merge it somehow, it's unclear to me how you distinguish what's experimental and what's already stable.
Yeah, well, I was thinking of this, of these moments where you would want to break the API. So there would be a difference between the old version and a new one. Because if you have everything together and everything has to move to the next version, that might mean a bit more maintenance work than perhaps absolutely necessary. Just a thought.
Ivan here. I would like to. So I agree with what Arjen said. It seems like we have some unnecessary maintenance work. So if I take linear algebra as the example, I I contributed the diagonal function and the trace because I was using them in a private code. But actually, all of the code that I've so far contributed into stdlib experimental, I've never used it in any of my production code because I'm hesitant to have this long module name, stdlib experimental. And then once we decide upon the criteria to move to stable, I'll have to go back and edit my code and remove this experimental. So I think currently from the user point of view for testing, it's a bit inconvenient.
It's a very good point, yes.
If I may, I agree with Ivan. But the other side, I also like to see that when I use something that is experimental and not stable yet, so that I'm aware of that.
Yeah.
So I guess the alternative to what we do now is to just have stdlib underscore linelg and have the diagonal function in it. And then you can use it right away, except that we decide, oh, we made a mistake, we have to change the API a little bit. Your code will break. So, and because it's experimental. And so I guess the question is, how do we convey the fact that diagonal is experimental? So what I thought, well, we'll have the module experimental, which is similar to what C++ does. When they propose a new thing, they always do like std : experimental : something. And so I thought that's a great idea. But if people think that's not a good idea, we can do something else. But I think we should still convey somehow that the diagonal function is experimental and can change or can be removed in the, if we realize, oh, maybe we made a mistake, or based on the usage, we realize, oh, we need to change it a little bit. Yeah.
Of course, experimental in the module name is absolutely the most explicit way to do it. The user can't not notice that because they're importing it from there. Perhaps not as explicit, but maybe it could work is if we clearly document it in the documentation. So I think if we look into Rust, which does semantic version releases, and if you look every release note, they also have there was actually one today. And in the release note, there's also a list of procedures and types and other stuff that was stabilized. So when you get a Rust release, you're getting everything, and the documentation tells you what's stable, what's not stable, and every release note basically stabilizes.
Okay, so actually, I like that you brought Rust. I always bring Rust because I really like how they do things. So
that's why I brought it up.
I should look into how they do it. So I need to look at it. But what you are saying is that they have an std. I know they have a standard library. And what you're saying, they just use documentation to document which parts of the standard library is stable and which is experimental.
Yes, and specifically, it applies to the whole of Rust language. So they stabilize language features in each minor release, and that's true of the stdlib as well.
Okay, well, okay.
It's an alternative approach. We shouldn't do something that we don't like or doesn't work for us just because a big language does it.
No, I think that yeah. So I guess the alternative. So they don't have semantic version. So it seems to me they have a semantic version of the whole library then, or how do they do it?
They have effectively semantic versioning of the entire language.
Oh, that's right. They tie it to the language. Okay, well, so what we can do, what we can do till next time, we can study how Rust does it. And it looks like that they don't version the individual functions, but they document documentation, which ones are stable and which ones are experimental. And so applied to our case, we would not have any experimental module. We would only have a linalg module or stdlib underscore linalg module. And we would document probably the source code and documentation somewhere, which is experimental, which one is stable. I think that can work.
Yeah, I think so too. I mean, with Fortran and the specs, it could be mentioned in both. That is experimental, and yeah, that's a good point.
I like it.
Okay, so here's a case that we haven't considered yet. All right, so let's say we're a bit further along and people are using standard lib in their applications. And maybe they've used some experimental features, and they've taken that responsibility. They've used experimental features. In principle, they should know what they're getting into. Now they pull a new version of standard lib, and their application breaks. Right. So then they come to us and they say, well, now my application broke, and it's going to be, then they have to dig through the diffs to figure out what changed and all this. And so on a certain level, yes, they assume that responsibility because they used experimental features. On the other hand, if you want people to use it, a lot of useful features are going to be experimental for a long time if we're going to, ensure backwards compatibility. So it's kind of hard to ask people not to use experimental features. And so, it's painful not to use experimental features, but then it becomes painful when they get changed on you.
Yes.
So
yeah. You are hitting, that's exactly why I initially realized or leaned towards having the experimental in the module, because from an application perspective, then you know that it's experimental. So if something breaks and you see that it's being imported from the experimental module in your source code, you see it there, then you know, oh, okay, yeah, that changed, that can change, I understand. It's kind of more explicit, because but I think if it works for Rust, I guess that's, I'm worried that exactly as you just said, that if we just put everything into we'll have no experimental module, but we'll just document what's experimental. It just becomes tricky for people to kind of quickly see what's experimental and what's not. But if it works for Rust and they manage to kind of make this work without people complaining, or I would say if they manage to kind of educate, their users how to make this work so that people are happy with that, I think we can make it work also. I guess that's.
I think the problem you've described, Nathaniel, is a more general problem of programming in general, and it's the way I understand it's solved is if you've got a production code and you've linked it against a version of the library, then you know that your code works for that singular version of the library and that version only. And then, like you said, when you bump the version, you have to go through a process of making sure, running all your tests and identifying anywhere where it breaks. But apart from that, as far as you're concerned, you only link against a single version of that library. So that's what a lock file would be for, right?
Yeah, so that comes to the FPM, and I think FPM might eliminate a lot of these issues. I agree.
Hey, Martin speaking. Can you hear me?
Yes, hi, Martin.
Oh, yeah. I use a lot the PETSI library from one of the national labs, and they also break their interface quite often, but it doesn't seem to hurt the use of PETSI. And they just document it, and if you break an interface, it's basically, of course, this modern form it because know how to compile it. So it's just a little bit of tedious work, but it's not something that is as bad as something like a real thing breaks under the hood and different.
Yeah, I agree. I don't think we can kind of avoid causing breaking changes for our users. It's just going to happen, but we can make it very easy for them in documenting it. And
I mean, so we can completely avoid it, just like Fortran itself pretty much avoids. I mean, unless some very, very corner cases, avoids all breakage, and you do it by just having a new module name. So you keep the old module forever, but you realize, oh, we really should have made something different. You create a new module with new module name. And in fact, that's how Python does it also. They had like OPT parse, and then they realized, it's not good enough. So they created arc parse as a new module, and they just keep both. That's one way to do it.
Shall we move the discussion on to strings? Because I think there's a couple of things to talk about there.
Yeah, strings and FPM then.
Martin, would you like to start? I think you have a proposal for strings and file system utilities.
Yeah, so to start with, I mean, I was not really focusing on strings. My idea was just to have common file system operations, because I mean there's something in Fortran, but not everything, like merging path, figuring out whether it's a directory or an actual file. I'm not sure if that is really important, and I have some code for that, and I thought it would be nice to contribute this to standard lib. And as it turns out, I'm also some code for doing file system operations. So as most of you the and has a state API. And yeah, would be quite helpful to have these small pieces. Some operations you have to rely on C. Yeah, just share the screen with a small presentation. I mean, it's not a proper presentation, but it's just some ideas.
Yeah, please go ahead. Is it me, or is Martin breaking up a little bit for everybody?
Yeah, it's breaking
Yeah,
up.
I'm struggling to hear you.
Oh,
Okay.
sorry. Yeah, I don't know what's wrong here. So I'm not allowed to share my screen.
Lawrence, do you know how to allow sharing the screen?
Let me have a look. What's happening when you try and share your screen?
Host disabled participant screen sharing.
Oh gosh.
Lawrence, at the bottom by share screen, there's a little up arrow. Click on that and then advanced sharing options. That should
Oh
let you
yes, I've got it. How's it? How about now?
Does anyone see my screen? You should be able to see it.
Yeah, we can see it.
I see
Okay,
it.
perfect. So yeah, I mean the general concept I would as if possible most of you will have like figuring out whether it's a directory. I think there's an Intel specific extension, but of course I don't want to use compiler specific vendor specific routines. One would need to see, which is yeah quite easy. Yeah, then I looked around. My main languages are Python and Fortran. So Python has two libraries. One is OSPath and the other one is pathlib. In Python, really is more appropriate. Yeah, open.
We are having problems hearing you, I think.
No. Can you see me now?
Yeah, we can see your presentation, but we cannot. When you talk, you break up. But from the presentation, if I understood from the slides, what you are saying is that there is a string and then a path, and that there are two different things, pathlib and OSPath, and also Rust actually has also something like pathlib. Yeah, I think it makes sense to do it as you said.
So there's yeah, there are two approaches in Python, and I think one is the one that I would go for is os.path, which is more the yeah, it's not the object-oriented approach, but the open, I mean, is of course want to use.
So I think, I don't know if we have, Lawrence, how much time is allocated for this?
Yeah, we're running a little bit over, I think.
Okay. We can continue this at some maybe other time and maybe in the issues. If you wouldn't mind, Martin, sharing your presentation so that we can schedule another call just to discuss this.
Okay.
But I think overall, I would say, yes, I think we can figure out something that we will all agree. I think we can, get it done.
Yeah, it seems like there's also quite a lot of prior art in this area, as even kind of quite extensively showed on the discourse. So there's a lot of work to draw on. It's just probably a question of how we bring it all together.
Yeah.
Does anyone have any kind of big points they want to talk about on kind of that topic? I think we can probably move on to discussing FPM now then, I think. So my idea was we could probably start off with people's experience of using FPM so far. I think what we've got at the moment is a really great tool, and it's good to see people starting to use it in their projects. I think one particular user who's not joined us has got quite a few of his projects now on FPM, which is really great. So from my point of view, I'm not quite using it just yet in my own projects because unfortunately, the way it is, it's with the features, it's binary, and if you don't have it, then you can't use it. So the features I personally would like are linking to external libraries like BLAS. I'd quite like a bit more control over compile flags and linking flags. And this one's a little bit less used, but I use submodules for everything. So I've already raised an issue for that. Does anyone else have any other feedback on FPM?
So regarding the flags, would it work if you would use the build script? What, I know there are some issues there too, but once we nail them out,
yes, yeah, I think a build script would basically fix everything because I already have a make file. I think, so I can in that sense, but in terms of using FPM natively, those are the kind of the big showstoppers for me at the moment.
But does anybody else want to share their experience?
I don't have strong opinion here. I've been following the discussion, but I just want to say I'm really happy that to see quite a few users start playing with it, and that we also have a few annoyed users, which I think is a very good sign because that means they care about this and they want to use the tool.
Yeah, it's really great to see that actually. So there's quite a lot of issues on the GitHub. I was wondering whether we might be able to possibly discuss a prioritization of those issues in terms of what we want to work on next, and also possibly discuss the rewrite in Fortran, which some people might not be aware of is planned, but I think that's the plan at the moment.
Yeah, I almost feel the rewrite to Fortran might be the highest priority because it would allow more people to contribute, I think.
Yeah. I think that's probably where we need to start next. Is we've identified a few kind of dependencies that we'll need to do the rewrite in Fortran, and I think we need to start focusing some efforts on getting those at least to a functioning state where we can start using them for the rewrite. The biggest one is parsing the TOML file, and then next after that is kind of the build system, which probably we could just piggyback off of make, but we need some way of constructing that.
So what I was thinking is people can help with the TOML file, and we can even, as for simple projects, you don't even have to kind of read the TOML file. You just kind of use the structure and to just get something going. And so what I was thinking is if we should just kind of create like the Fortran executable and like some basic Fortran files so that people can start contributing, and then we'll create the TOML third-party package in Fortran probably. Again, just with bare minimum, and then people can start contributing, So what I'm trying to say is that just setting up the infrastructure, I think, if we can do it, then I know people will help. I'll help.
Okay.
That sounds good. Are we kind of considering continuing parallel development of the Haskell version, or are we freezing that one?
Well, I think what we discussed in the past is to keep it alive. If nothing, at least to be able to bootstrap it. For example, the TOML package will be a separate package, but FPM depends on it. So you want to use some, you want to use FPM to develop FPM. So you need to be able to bootstrap it. And the Haskell package right now seems very close to have the minimal features to actually get us started. So I think we definitely have to maintain it for a while, maybe for a long time, who knows. But I think what we discussed is that to keep the features in the Haskell package kind of minimal, just to allow us to start the Fortran, and maintain, so to say, the Fortran version.
Yeah, I think we want to kind of minimize any additional features that go into the Haskell version. And basically the only new features we should add are things that we need for getting the Fortran version working.
Yeah, that sounds reasonable. That sounds like a good start. It's yeah, I agree. I think getting the infrastructure ready for the Fortran one would be good. Get people contributing to that one. And I see Evan's just pointed a link to a Fortran TOML parser too. So we might be in luck there, I think.
Yeah, we'll have to take a look at those and see how well they work.
I think we just need to fork them and create our FPM file. So we can use the Haskell FPM to bootstrap the Fortran one.
Yep.
And Brad, your ISO varying string is already, so it already uses FPM as I saw. So maybe that's already enough to get us started.
Should be.
Very nice. And management-wise, should this be its own repo or a development branch in the existing repo? What do you think?
I would add it directly to the master branch so that people can just use it, and maybe we can rename the Haskell FPM like FPM Haskell or FPM Bootstrap maybe, and that way the FPM. Well, we have to talk about it, but so it's always hard to start it. But once it's going, what I was thinking is having FPM Bootstrap be the Haskell version, and FPM will be the Fortran version. Until we get there, maybe we can start with FPM Fortran, binary. That way it doesn't clash and people can keep using the FPM until we reach parity with features, and then we can flip it, for example.
Yeah, I think the approach should probably be to have the Fortran version be its own project until it reaches parity. And then we can switch them, and then people will be able to keep using it without really even noticing.
So when you say project, are you thinking of having like a separate repository?
Yeah. Because if we have them be separate repositories, then it avoids the complications of having people learn how to do development cross branches. Because if you're using FPM to develop the Fortran version, well, you may need to switch back to the master branch, compile the Haskell version, and install it, and then you can switch back to the Fortran branch so you can keep developing the Fortran version.
So I was thinking not using branches, having everything in master, having both the Fortran and Haskell version in master.
Okay. Probably be done, but you have to organize things so that they're not in each other's way.
Yeah, this is a bit confusing to me as well, to have them in the same branch, same repo. And in addition to this, I think it may be useful to also separate the client implementation from the specification. Where both existing Haskell client and Fortran client could follow the same spec. So in a way, we would have a document to work, to follow and work after.
And what about things like the issues? So if we have a different GitHub repository, we'll have no issues there. But so then people will be reporting issues on two repositories. It will be like, once we are done, will we always have two repositories, or?
I don't know.
It seems to me just having just one
Yeah.
FPM repository, and so we already have the Rust version that I initially wrote in there, it's in the archive directory. So what I'm thinking, we can have a directory, Fortran, whatever we call it, and just develop everything in one repository in master, and have the Fortran version in the repository, in the directory, so that way it doesn't clash with anything. You just have to bring it up to speed, and I think it just makes it easier for people. It's just one repository to deal with. And then once we are done, then we can move the Haskell version to its own directory and just make the Fortran the main thing.
Would this work, running FPM on the FPM repository?
Well, that's how we want to develop it. Once we, why wouldn't it work?
I don't know.
I think what we will want to do is just put both in their own directories. So neither is the top level is at the top level, right? So it keeps them completely separate. But I think having them in the same repository will actually make the specification and the testing of the parity a little bit easier. So that may be the way to go.
Exactly.
And then we don't have to worry about the issues getting scattered between different projects either. So that may be the way to go.
Yeah, and the tests, that's the key. I forgot to mention that we want to run the same test suite with both, so having it in the same repository just makes sense, and people keep reporting, and it just makes sense to me.
I guess this
I've got a question
to Milan's point, which is we should really start to put down in writing the specification for at least a draft specification for how FPM is going to work, especially since it's possible that a lot of the issues that people are having at the moment are just with the interface and how things are written in the TOML file. So making a start on that might be a good idea.
Nathaniel had a question.
Yeah. So longer term, let's say when the Fortran implementation of FPM is usable, is the vision still that a user has to bootstrap it off the Haskell version, or do they never need to touch the Haskell version?
It could go either way. What I was thinking is, so we would distribute it as binaries. So if you are okay installing a binary, then you just install the FPM as a binary, and that's all you need. Then if you want to install from source, then what I was thinking is having two options. One is maybe having the Haskell version, but the other option is that I really would like FPM down the road to be able to generate CMake build system, for example, or just make. And we can keep that CMake build system checked in the Git repository, so that when you bootstrap it, you just run CMake first, just to build FPM the first time, and after that you have it built. So I think there are multiple options in the future how we can bootstrap it from source.
I agree. I think.
Okay, yeah, because the word, yeah.
Sorry, go ahead.
Yeah, just the concern that I had is, say I've got a new allocation on the cluster. Am I going to have to install, the Haskell stack on the cluster?
Yeah, so this is what I was about to say.
I
think we should have another more common build system like Make or CMake for this exact reason, because installing Haskell is quite difficult when on those systems.
Yeah, exactly. And I think the CMake system can be automatically generated by FPM, because FPM knows everything about how to build the project. The only issue is with dependencies. So of course it will depend on a few packages, but I think we can automate this somehow. FPM ultimately knows everything, or will know everything, so it can maybe create like a bootstrap tarball where it will include the dependencies and provide CMake build system for this all of this. Just so that people can build it from source on the cluster.
Andre,
okay.
I think when you say FPM Fortran will be able to be bootstrapped by FPM Haskell, you're really saying FPM Fortran will be an FPM package itself.
Yes. Yes.
So you could build it with whatever FPM you got,
yes,
or in other ways.
Yes.
Yep, that's the idea. Okay. Anything else, FPM? Any questions? Any other users?
So I think now that people are starting to put some packages together, there's been discussion of having a central repository, and I know we've got an issue open for a minimal package registry. Is this something that we can start doing now, or are we still waiting out on any particular implementation details?
I would lean towards waiting, because the Haskell, I think we want to avoid adding features to the Haskell version, which would be necessary for getting packages from the registry. Right?
Yes.
So we could construct the registry and come up with a design for that, but the Haskell version wouldn't interface with it.
Yeah, that makes sense, I think, yeah.
I agree, and there may be an alternative where perhaps for now we just have a hand-curated list of packages and links, just so that people can read and see, hey, these are the things that I can build with FPM. I think that will help grow the user base. We don't worry for now about the registry getting things working from machine perspective. And perhaps we can show this list on the website too, as it's on page.
Yeah, so we have 3 issues for the registry, like a step-by-step. And the very first issue is what Milan described. It's just having a hand-curated list of things, and maybe as a JSON file so that we can put it on a website, with some nice, web page and so on. Next step is to then, add more features. And the very next step, I think, is to integrate it with the FPM tool itself. And then the last step is to have a centralized registry. So we can just do it step by step.
Mm-hmm.
So I guess it makes sense to make a start on the minimal kind of list, just so people can.
I think so.
Yeah.
I think we can do it right away. Have a JSON, and put it on the Fortran, maybe Fortran Lang website even, and then just go from there.
That sounds good. Okay, so I think we're just about coming up on time then. Does anyone else have any things we want to go back to or discuss just in the last couple of seconds?
Well, I have a quick, maybe silly question. Going back to the single repository and 2 versions of FPM, so Fortran and Haskell FPM, would it work with branches? I mean, maybe it's a very basic question, but why not branching, simply create a branch for the FPM Fortran, and then we can merge it or whatever is going to happen in the future? Why this should not work?
It can work. It's just a question of which one is the easiest for development and as well as users.
Yeah, I think for a lot of the development process, it's going to be easier to have them side by side than to have to use Git to switch between branches on a regular basis. I think that's going to happen frequently, where you want to switch between versions, and so having to manually do that with Git will be a little bit inconvenient.
Okay, I see. Thanks.
I also find it a bit scary to do that. You lose your files.
Yeah, I think for simplicity's sake, we can stick with the single repository then. Okay, then. Well, thank you everyone for participating in the meeting today. There's quite a lot more to discuss, so we can continue that on the GitHub and in next month's meeting, I think.
Thank you, Laurent, for organizing it.
Thanks.
Yep.
Thank you.
Thanks, everybody.
Thank you all.
Thank you. Bye.
Bye.
Bye. Ciao.
Yeah, really good.